This video is going to cover Unit 14.5 and Unit 14.6. Unit 14.5 is solution of equation by the division principle of equality. Now, the division principle of equality states that if both sides of an equation are divided by the same number, the sides remain equal and the equation remains in balance. So the division principle is used to solve equations in which a number is multiplied by the unknown, such as 3x equals 18. Now, to solve for x, remember, when we're solving for an unknown, we always want to get the unknown on one side all by itself with a +1 in front of it. So how do I change 3 into 1? I divide by 3. Any number divided by itself is a 1. So divide that by 3, that becomes a 1. So in order to maintain the balance of the equal sign, I have to divide this side by 3 as well. So 18 divided by 3 is 6, so x equals 6. Now let's take a look at some of them on page 433. Let's look at number 11. Number 11 looks good. I've got a negative 27 is equal to 3y. Okay, so I want to get the y all by itself. So I divide that by 3. Then this becomes a 1. Divide this side by a 3. And a negative divided by a positive is a negative. 27 divided by 3 is 9. So y equals a negative 9. And you could have some with decimals in it, like number 21, where we have negative 2.7x is equal to 23.76. So we divide both sides by a negative in this case, negative 2.7. So this becomes a 1. So divide this side by a negative 2.7. So x equals positive divided by negative is a negative. And 23.76 divided by 2.7 is equal to 8.8. So a negative 8.8. Now they have some that have mixed numbers in here and stuff. But let's try number 27. Number 27 is a negative 0.66x is equal to 4.752. So we divide this side by a negative 0.66, so this becomes a 1. So I'm left with x over here. Divide this by a negative 0.66. And a positive divided by a negative is a negative. And 4.752 divided by 0.66 is equal to 7.2. Ta-da! Now, let's move on to 14.6. Solution of equations by the multiplication principle. The multiplication principle of equality states that if both sides of an equation are multiplied by the same number, the sides remain equal and the equation remains in balance. Same kind of wording that we've had so far. So the multiplication principle is used to solve an equation in which an unknown is divided by a number. So that is the same thing as saying y divided by 7 equals 42. I'm going to show you two ways to take care of this problem. One way is, since it's being divided here, I'm just going to multiply that by 7. So this right here becomes a 1. So if I multiply one side by 7, I need to multiply the other side by 7. So y is equal to 7 times 42, 294. Now another way to look at this, instead of y divided by 7, I can say that this is 1/7 times y equals 42. Now we have the 1/7 over here. So when I have a fraction, if I multiply a fraction by its reciprocal or inverse, it always becomes a 1. So any fraction multiplied by its inverse is 1. The inverse of 1/7 is 7/1. As you can see, it'll be 7/7. It's the same idea, but it's just a little bit of a different way to look at it. And of course, we multiply this side by 7, or 7/1. This is already over 1, so y will still be equal to 294. So let's take a look at some of these. On page 436, let's just look at the first one, number 7. We have, I'm going to write it this way, 1/5 times p is equal to 4. So I'm going to multiply this by the reciprocal. Multiply this by the reciprocal, which is 5/1, or just 5. This is a 1, so I have p is equal to 20. And let's take a look at number 37. Number 37 is 2/3 b is equal to 5/2. So once again, the reciprocal of 2/3 is 3/2. So 3/2, this becomes a 1. So I multiply this side by 3/2. And b equals, let's see, 15/4. So 15/4. Now, leave it as an improper fraction. Do not change that into a mixed number. Or, I guess technically you could make it a decimal if you wanted to. But improper fractions are significantly better than mixed numbers. Okay, let's see if one more here. Let's take a look at number 38. Number 38 is 5/8. Now, the e is in the numerator. I'm just going to move the e out of the fraction and write it right there. And that is equal to 3/4. So I multiply both sides by the reciprocal of 5/8, so 8/5. I don't need to actually do this multiplication. I just know that that is going to be 1. So we multiply this side by 8/5. There's a little bit of cross canceling I can do. I can divide that by 2 and divide that by 2 and get a 4 and a 2 right there. So e will equal 12/10. If you don't see that cross canceling, that's fine. There's nothing wrong with that, but just note that there might be some simplifying to do or reducing to do after, which we still have. Even though I cross-canceled, there's still some reducing to do because both of these are even numbers. So I can take a 2 out of both of them to get 6 over 5. All right?